This is a very short section, a very short video on with just one topic in it. Here we're going to be talking about elementary row operations on matrices. These are the things that you can do to matrices, and specifically these are the things you could do to rows of a matrix. So let's get started. For demonstration purposes, I'm starting with a matrix A, which has rows 1, 2, 3, and 4, 5, 6. As a reminder, this matrix will have come from a system of linear equations where the coefficients of x and y in the first equation are 1 and 2, so I have x plus 2y, and the constant term was 3. And the second equation would have been 4x plus 5y equals 6. And that's just a reminder of where the matrix came from, because some of these row operations are easier to describe, easier to understand if you know that what you're doing is really not any more than operating on an equation, right? We know how to do stuff to equations in one or two or multiple variables in from algebra, but in the land of matrices, we could do the same thing, and it's easier to sort of hang that on the framework of doing it in the world of equations. So let's get started. We have three different kinds of things that we can do. One of them is to reverse the order of the rows. So I can write A as 1, 2, 3, 4, 5, 6, or I can write it as 4, 5, 6, 1, 2, 3. And the reason I can get away with that is because all I'm doing is writing the system of equations in the opposite order. I'm writing the 4, 5, 6 one on top and the 1, 2, 3 equation underneath. I haven't changed the equations at all. I haven't changed their relationship with each other except to write them down in a different order. So I'm allowed to do that to a matrix because I'm allowed to do that with two equations. Matrices are just a record of the coefficients in a series of equations, a pair in this case, but any system, right? A system of equations is just a list of equations, and you can write those equations down in any order. Of course, we have some annotation here. What I'm going to say I did is I took row 1 and I interchanged it with row 2. In general, I will say that I took the ith and jth rows and I interchanged them. Now, I'm using j a little bit differently here than I did in previous videos, but I and j are just indices. They're just generic unknown values, right? So some row and some other row were reversed, right? Interchanged. So that's one thing that we can do with matrices. Let's go ahead and highlight that. Right, you can interchange two rows. Something else that we can do is we can multiply any row by any non-zero constant value. So for example, I might want to multiply row, I'm going to go back to my original matrix A here. Let's say multiply row 1 by -2. That's going to give me a new matrix. Negative 1 times -2 is -2. 2 times -2 is -4. 3 times -2 is -6. And then I'm just going to copy down my second row because I'm not operating on the second row in this example, just on the first one. I'm allowed to do that. Let's draw a line between these guys. I'm allowed to do that because, again, if I started with x plus 2y plus, equals 3, and 4x plus 5y equals 6, that's the equivalent of multiplying both sides of this equation by -4, or sorry, -2, right? Because the row in a matrix is just the coefficients of an equation and the constant term. So my new system of equations, if I write it as a system of equations, is going to be -2x minus 4y equals -6, and 4x plus 5y equals 6. Now, if I were to take this system of equations and write it as a matrix, I would get that. I would get that matrix that I had in the first place, that I got simply by multiplying row 1 by the value -2. What I've done here can be annotated as having taken -2 and multiplied it by row 1. My pen just stopped working. And put that in the position row 1, right? So we didn't move row 1, we just multiplied everything in row 1 by the number -2. In general terms, I can take any non-zero constant, multiply it by row I, and put it back in the position of row I. So let's highlight that one as well. So that's something else that we can do. This is a second row operation that we can perform. There's one more. I can take a multiple of row 1 and add it to row 2, or a multiple of row 2 and add it to row 1. Let's see, in this example, let's say I decide to multiply row 1 by -3 and add it to row 2. This is actually two different operations, but the way your textbook annotates it, the way it describes it, it just puts them all together. What I'm doing here is multiplying row 1 by -3, which is the same as I did in the second example, the description of the second property, the second operation that you can do on matrices. And then I'm going to add two rows together. The new row 1, the one I get by multiplying it by -3, and row 2. So I actually feel like this should just be, you can add two rows together. This operation should just be that you can add two rows together. But your textbook, and frankly many textbooks, describe this as a kind of a combined thing. So I'll go ahead and stick with their way of describing this. So I'm going to take row 1, I'm going to multiply it by -3, and I'm going to add it to row 2. Okay, so that's going to change row 2 this time. It actually could change row 1, but I'm just going to do it this way. So I'm going to start by multiplying row 1 by -3. I'll use some scratch paper here. That's -1, -6, -9. And then I'm going to add that to row 2, which is 4, 5, 6, which gives me 3, -1, -3. And that's what's going to go in row 2. 3, -1, -3. So that's my example for this one. Again, you can talk about getting away with this in the same way as we were able to talk about getting away with these other operations, by simply describing that what you're really doing is operating on an equation. You're just doing it without the variables. You're just operating on the coefficients, because the operations that we've done don't affect the variables anyway. They only affect the coefficients. So I'm not going to write that part out this time. I'm going to use the extra space instead, just to say that the way we annotate this in sort of generic, well, let me do it the way I did it first. I did -3 times row 1 plus row 2, and I put that in the position of row 2. Okay. In general terms, I can take any constant, non-zero constant, multiply it by any row, add it to any other row, and put that in the position of either the ith or the jth. So I've got I here and j here. I can put it in the position of either, right? Your textbook uses j, but you could actually replace that with, replace either of the two rows you've manipulated with your new string of values. So that's pretty much it for this video as well. I'm going to highlight this last property down here. So those are the three big takeaways from this video. The fact that you can reverse the order of two rows, right? We've got this one here. You can multiply any row by a non-zero constant, or you can multiply any row by a non-zero constant and add it to another row, and then use the result to replace either of those two rows. Why a non-zero constant? Well, it turns out that if you multiply 0 by everything in the row, you're just going to get 0 and 0 for everything, right? And that essentially renders the matrix unusable for the purposes we're going to use it for. It's algebraically legal, but there's really no point in doing it. It changes the solutions, potential solutions of the system, and it just messes everything up. So we have to use non-zero constants here and here, but as long as we do, it can be any real number that we can do that with.